All right, welcome back. And today we are going to do a question called check palindrome. So let's read the question here. So given a string, determine if there is a way to arrange the string such that the string is a palindrome. If such arrangement exists, return a palindrome. There could be many arrangements. Otherwise, return none. So basically in this question, if you are given a palindrome or just a string, then you're going to determine if it's possible to make it a palindrome or not. And palindrome, what it is basically if you read it from left to right is the same from right to left. For example, this one is already a palindrome, but you can also change it such that you make it like this, Momo, and this would still be correct because with the letters, you can definitely make a palindrome out of that, and then you just return one of them. Here's an example of what you cannot make as a palindrome. Something like this is impossible because you're just not going to be able to make a palindrome out of it. Okay, so the key here is remember that a palindrome reads the same from left to right and right to left. So that means that if ever there's a letter here, then at the end of it, you also have to have the same letter. So that means it's going to be an even number of letters, except for maybe in the middle, where the middle can be a single character. Let's go to the drawing board to make this more simple to understand. Let's talk about an example of a palindrome. So imagine we have, if a palindrome, it starts with an A, then at the end, it has to be an A. And then if it's a B, the end has to be a B because it has to be read from the same from right to left as left to right, right? So that's why, because of these pairs, you are guaranteed that the letters have an even number of them. So for example, here there are 2 A's and there are 2 B's. And then if we add another A, then now it becomes 4A. The only time that you can have an odd number is if it's in the middle, if it's a C here. So then there's 1 C, right? And then you could also change it. Imagine we take out these C's, then we have the C's here, then we have 3 C's. There could only be one odd number, and then every other letters, they're going to have an even amount of them. So that's like a rule of a palindrome. All right, cool. So let's erase this, and then we're going to be talking about the actual question itself, where given a string, it doesn't have to be a palindrome, but determine if it can be a palindrome. So now that we know that palindromes have all even amount of unique letters, or one of them that is odd, then we can use that constraint or that theorem in some ways to do our question. Okay, let's take the example of M-O-M-O-M. So how do you know if it is a palindrome? So we're going to do this in 2 steps. First, we're going to make sure it is a palindrome, okay? Because if it is a palindrome, if it's not a palindrome, then we could just return none. But then if it is a palindrome, then the second step is to actually output that palindrome, okay? So first we're going to scan through the whole string so that we can get a dictionary of the counts. So once we scan this whole array, what we're going to see is we're going to get a dictionary that looks like this. We're going to have M equals 3, O equals 2, right? So we're going to get this after we've scanned through it. So we're going to have this called like char count. This is our dictionary right here. Okay, so now that we have that, that's great. And then with that, we can kind of determine if it's a palindrome or not. So what we can do is we can go through the whole dictionary and then maybe have a variable that's called like odd character. And then for now, it's set to nothing. And then if ever we see an odd character, then we modify it. So for example, we see M is 3. So this is an odd character. So we're going to have M here. And then let's have another variable called, let's just call it palindrome. And then what we're going to do is whenever we see an even number, then we're going to add to it. So here we're going to add O. All right, cool, excellent. Now this is almost complete, but we also want one thing. We want to make sure that whenever we see an odd character, not only do we just add the odd character, but we also add it in Palindrome, because depending on how many you can add. So we're going to divide this by 2 and we get 1.5, but we're going to just take the quotient of it. So it's going to be 1. So that means how many m's do we put in here? We're going to add 1 m. So in Palindrome, we're going to get MO. Right, so we almost do the same thing, but we're gonna redo this. So instead of just adding the letter, what we're gonna do, we're gonna divide the count by 2, and then we're going to add the letter. The reason why we're gonna divide by 2 is because we're gonna reuse this palindrome to create our string, right? So now that we're able to go through the whole dictionary and get odd character and then palindrome. So odd character will be the middle character that we will want. And then palindrome would be from left to right. So for example, this is essentially this guy. And what we're gonna do is we're gonna reverse it, and then also get OM, and then this will be that guy. And then for odd character, this guy, he's going to be in the middle. So this is essentially how we're going to be doing this. We're going to use palindrome. We're going to construct a palindrome string so we can build the string from left to right, so this guy. And then what we're going to do is we're going to add the odd character in between. And then finally, we're going to reverse palindrome and then put the characters here. And then what about the state where there's no palindrome? So what would happen is once you go through the dictionary and you see an odd number, you're going to be adding a character into the odd character. But once you see another, imagine if I had another odd character, for example, like K equals 1, then I see that I already have an odd character. So that would be impossible. And then if I see another odd character, then that means you cannot make another palindrome. So then you would just return none. Here, fortunately, we have the correct number of letters and it's okay. We only have one odd number, so that's fine. But imagine if we do have like a K here, like imagine if we changed it to K, then what's gonna happen is we're gonna have odd character. Here's gonna be like K because we saw K first, and then later on, once you go to M, we'll realize like, oh my God, you know, there's already a K here. So then we're gonna return none, and then that's how we know it's not a palindrome. But if it is a palindrome, then we want to construct palindrome and also odd character, so that later on the final string we're gonna return palindrome plus odd character plus the reverse of palindrome. I don't have enough space, but yeah, so you get the point. So we're going to be returning that, and then that would be our output. All right, so let's code this up. But before we code this up, can we talk about the time complexity and the space complexity? Yeah, so the time complexity would be, so we have to go through the whole string, so that's linear, O of n, and then later on we have to go through the whole dictionary, which is also O of n. So that means the time complexity will be O of n. And then in terms of space, because we have to build this dictionary, and then this dictionary is based on the string, so this dictionary, the worst case scenario is that we have every character and they all have like ones, so then the space would be also O of n. All right, so that's pretty much it for the time complexity and space complexity. So next what we're going to do is we're going to code it up. All right, cool. So we just have to modify this find palindrome function. So let's just do the same thing. All right. So first I want to import one of my favorite dictionaries. It's called default dictionary. Default. This default dic just allows me to create a dictionary where the default of a non-value is 0. So that means if ever we don't have a value, instead of needing to create the key, then we could just add 1 to it and it'll increment by 1. So that's what default dic is for, is so that we can default the integer values to 0 if we don't use it. So first what we're going to do is we're going to build this character count. So that's what we did last time with our dictionary. So for C and S, we go through, for each character in the string, we're going to build the dictionary. every time we see one, we're going to add 1. So now we want to initialize 2 variables. One is odd character, and the other one is palindrome, like we did on the drawing. And then next, what we're going to do is we're going to go through our dictionary, and then we are going to be constructing our odd character and our palindrome. So for character, and then whatever their count is, so we're looking at the key value in our character count dictionary. And then we are going to see if they are even. So if count modulo 2 equals 0, that means they are even. Then we're going to add the string. We're going to add the character, how many times? Divided by 2. So we're going to add that many times because if we saw 6 characters of O's, then we want to construct our palindrome with 3 O's. So we can kind of mirror it, and then it's going to multiply by 2, so we're going to get 6 O's again. All right, cool. And then the other case, it's not odd. If it's not odd, then we want to see if they're already an odd character. If there's already if there isn't an odd character, then we're going to set the odd character to whatever it is that we saw. And then we're also going to start building the palindrome. Okay, same thing, times count. All right. So this is the quotient. So we won't get like a floating number. We're just going to integer, which is perfect. So for example, if we had 3, if we divide by 2, it's not going to give us 1.5. It's going to give us 1, which is exactly what we want. And then if it's not odd, no, and also we already have an odd character, then we're going to return none because it cannot. Because it cannot be a palindrome. That string cannot be a palindrome. All right, and then if it is a palindrome, then it's going to go through this loop fine, and then now we're just going to build our string. So like we said, we want the palindrome, and then also the odd character if we do have it inside. It's possible that there isn't any, and then the palindrome but reversed. Palindrome. And then this is just a short form in Python to reverse it, to reverse the string. All right, let's run it. Oops, I forgot items here. All right, so let's run it again. Okay, cool. So excellent. So this works. And then this one gives us none like we expected to because it's not a palindrome. And then, for example, if we add k in here, so this would also be none. So we're going to get 2 nones. All right, perfect. And then, yeah, we could try another example. Yep, perfect. All right, cool. So, yep, so that's pretty much it. And yeah, I hope that was interesting, and see you on the next one.